Yeah. Okay, I put the link in the chat. And let's pick up where we stopped last week, but because Eric wasn't here, let me refresh what we did and what we didn't do. The goal is to try to figure out what a modular YakRover kit would look like. And the way I did it was in a 6-step process. Intro, which is we're doing now. Next step, I have a list of subjects here. Each one takes a subject and suggests between 3 and 5 alternative designs, and writes down 2 or 3 questions that occur to them while they're doing the work, which helps, lead or focus or whatever. Then each Yak presents the ideas and questions. Next step, where it becomes interesting, we take subjects, pairs, and we do this live. We take pairs and try to talk about how the ideas from one group. Okay, hi Robert, we're recording.
Yes, the lady told me. She has a very sultry voice.
Yeah. This is week 2 of the Modular YakRover brainstorm. And in the first step, there's a list of subjects, which I'll go through in a minute. And each one chooses a subject and on his own write down 3 to 5 alternative designs, and then 2 to 3 questions that occur to them. Then each one presents the ideas and questions. Then live, each one selects a pair of subjects, let's say data power bus and mechanical connection, and writes a bit about how they might work together. And then we have summary. Now I took the subjects from last week and I added a few more in order to make sure that nobody's left not holding a subject in the bag. So last week we talked about data power bus. Joshua did that. Electrical connections, nobody did that, it's waiting. Mechanical connection, Venkatesh did that. Diversity in parts versus alternatives, I did that. Vet did software modularity. And here's another subject which nobody did, brain and internal organs, CPU, power supply sensors, configuration. In view of the stuff Joshua has been doing, I added one which is modularity on an existing bot. So we have a robot of whatever design and we want to use modular components to extend it. Base station. I specifically selected out power supply from all of the brain and internal organs if somebody wants to focus on that. And sensors and end effectors. So like last week, we're not going to do all of the subjects. Each one choose one subject, please. Write your name next to it. And you can see from the examples, write down a few ideas of how you think it might be done. Okay, it's brainstorming, so the ideas can be shallow but diverse. And then write down the questions. Any questions to me? Okay, the link is in the chat. The link to the homepage. And also, in the server. I'm waiting for you all to choose. I'll choose last.
Oh, and for this first round, can we add a couple of minutes to the time? Because I think I'll need to review what we did last week just to refamiliarize myself. So let's take a little longer. And also,
So let's do it the other way around. Let's spend a few minutes going through what we did last time for everybody, and that will also put us all on a even plane.
Sounds good. And also just wanted to say by way of introduction, Robert and I, we know each other from before we first met, I think around GTD's, David Allen's GTD company, like more than 15 years ago. And he's got like two lives. He's an IT computer systems guy and also acclaimed and published poet based in the UK now. And he's written 3 or 4 poetry books, which I think I would say are responsible for getting me back into poetry in my 40s. So yeah, that's Robert. Yeah, you want to say hi, Robert, and
Well,
introduce-
that's a wonderful introduction. I didn't realize that influence. Thank you, Venkat. That's I'm like blushing at this point. So it's wonderful to hear. Yeah, just very intrigued and interested to show up, participate, see what you guys are doing, hang out. So happy to be here.
Okay, so the first subject we talked about last week was a data power bus. Okay, and Joshua took it in the direction of a bus which knows how to provide both data and power. So think about if you have a rover and it's modular, you need to get data from one place to another and power from one place to another. And there were different types of solutions, like using existing solutions like single pair Ethernet, optical connections, maybe wireless. And of course, I'm not repeating everything. And some questions, just to give you an example, what is the cost benefit of consolidating the two of them together versus having them separate? What's more rugged? Okay, so that's one item we talked about last week. Another one is mechanical connection. How do we connect together two components? And Venkatesh took it also a little bit in the direction of what does the components look like? So for example, different ways of looking at the size of the component. It can be a subatomic connection, can be atoms that connect. You can have edge heavy modules, or if we can really go crazy, maybe some sort of gray goo, very, very small things that connect together. And just as an example question, what do you want more? High strength, but then a human might have to put them together, versus low strength, which maybe the device can itself put together. I talked about diversity in parts versus alternatives. In other words, if we build the kit, is it a lot of pieces which are exactly the same? A lot of pieces that are different. Think about Lego, there's different types of sets. So for example, you can have a basic building block. You can have standard interface like you have in Lego, but inside everything is different. We can have a 2-level set, some parts that are standard, some that are not. And one of the questions is, how do we help users add components? Remember, it's a kit, we want other people to make it. How can we let users add components and still these components will enhance everybody's modular systems? Red talked about software modularity. And of course, one of the natural directions is ROS. And the question is, can we really do ROS in what we're talking about? Maybe we can look at the direction of what he calls microcontroller stack. Everything, but everything is inside the microcontroller. And then the natural questions is, are there stacks we know about? Do we want to be part of an existing ecosystem? What kind of reliability are we talking about? That's what we talked about last week. And we also talked about combinations, but we don't need to talk about that now. So does this put everybody on a even plane? Okay, so until 10:30, each one please choose one of the subjects which wasn't taken, write your name next to it, and shoot out some ideas and questions. Okay, yes, this is natural. Well, this is a bit like making popcorn. You listen at the microwave when the corn stops popping. So when the document stops popping, we can continue. Okay, people, ready to go? Okay, so Eric, can you go first? You have 5 minutes.
Okay. So for number 6, it's called brain and internal organs.
Mhm.
So I understand this as all the pieces, all the pre-built pieces we can put together to build a rover. Okay. So the examples are CPU, power supply, sensors, and so on. So in terms of if we look at these as organs, okay, it seems to me that there are 4 main. So first, it's about the idea is to identify the categories. Okay? Why? Because the categories are the boxes that we need to fill to make a complete rover. Okay? And so it seems that there are 4 main categories of organs. Okay? So compute, so the CPU and so on. Power, like the batteries, but also the power source and so on. Sensors, so the lidar and so on, and but In this category, I also include communication and radio and actuators. So for categories, at this point, I don't think about others, but there may be. After something, since we're talking about modularity, there is this notion derived from MVPs that we could call here as a minimum viable organism. Okay? So the idea is to have, the Russian doll kind of thing. Okay, that what are the components to make really the minimum rover, okay, in terms of energy usage, in terms of capability, okay, without anything redundant or anything good to have, let's say. Okay. So, for example, we can have a rover that is. We could choose that the minimum is so the body with the wheels, some compute, okay, not full compute, but some compute, and radio, for example. Okay. So actuators would be for us a couple of motors, okay, and maybe no sensor. Okay, it would just be a mobile robot. And then on top of that, we will have another level where we add, for example, more compute. Okay, a compute that can do deep learning, for example. Or add more sensors, so for example, to add an optional LiDAR. And on top of that, to have several layers we can put on top. So it's one vision of modularity. It's different. It may be different from a subscription architecture on which we come back regularly, okay? In the sense that of something I will be talking about later, which I call the criticality. Okay, I will come back to that in a moment. Next point is about redundancy, fallbacks, and fail-safes. Okay, so how to structure these MVOs, okay, I think is about the functionality that things the extra components provide. But a component provides a functionality to the whole system. But it's not, I don't think the relationships are linear. Okay, some components are more critical than the others. Okay? So over the past few weeks, we talked about, for example, two kinds of compute. Okay, we talk often about the Lisa brain. Okay, that could be a simpler microcontroller, and of the higher brain that could be a full SBC, okay, single board computer. Here we can see that to some extent these two components are redundant, but not completely, because it depends to what we ask them to do. Okay, but there is for example a fallback relationship. Okay, if the higher brain has more chances to be to fail. Okay, so there is a fallback on the Lisa brain. Okay, stuff like that to think about. There is also the notion of fail-safe, okay? Because maybe we would like the Lisa brain about mobility to be a fail-safe, okay, and to be more reliable. Okay? So typically, if we look at rovers that have legs, okay? For example, the spider boat we've been using, okay. Something we want to make sure of is that when there is really a problem inside some of the core components, okay, a fail-safe situation is that to guarantee somehow that the boat stops in a safe position. Okay, guarantee that mechanically it will end up this way. Okay? So such kind of thinking. Okay? And this thinking helps to structure the different layers of MVOs. Okay, it's a kind of guiding principle. Other ideas. Sorry, I didn't check at what time I started. Okay, but I will go quickly. It's about scavengability. That's something we talk about also regularly. Okay, so with these layers of Russian dolls, okay, we can remove the layers when we scavenge a rover, okay, but to some minimum that we need to identify. And here, this is where the notion of criticality comes into play. Okay, is to see when we choose components, these components have relationship to other components. Okay, and so, for example, in distributed systems, there is this notion of criticality, where a simple idea is to say when a component has more connectivity to other components, then it's more critical. So such kind of things that could be measured, okay, and would also be a guiding metric into how to structure these MVOs if the notion matters. Okay. Another notion of task availability is swappability. Okay, and so the idea that we have a bunch of components, okay, and so when we do maintenance, we can swap components, but some are harder to swap than others. Okay? So what is the impact on the list of organs?
Eric?
Yep.
I'm sorry, but your time is up and we have
Okay.
6 people. Robert, you're next.
Coming in cold, so all of my ideas are actually questions, and all of my questions are probably silly ones. But yeah, I mean, you can read the bullet points, but briefing basically around when you say configuration to a software person, I'm thinking about central versus decentralized. So interesting that you were earlier talking about the kind of, you know, SBC executive function and the sort of microcontroller lizard brain, because I guess a lot of this is riffing around the idea of to what extent do you need to centralize configuration and distribute out, or to what extent do individual components need their own individual configurations? Again, I'm thinking software configuration. Out of the software world, the idea of declarative forms of configuration, right? So that they basically, as applied, preserve state rather than try to declare operations. I think is useful when you're trying to design anything that's robust, whether it's a fleet of network connected components or components that have to talk to each other in a robotics context, which led me on to just again, a breadth of ideas rather than necessarily good ideas, kind of the neurology of the octopus, so the notion of having degrees of autonomy in the feedback cycle between sensing, processing, and actuating that can be configured on their own. Easter eggs, why not? So throw in some ASCII art. Environment is configuration. This was just the idea that not everything it needs to be internalized. The more that you can externalize things, the more sometimes they're robust. So having beacon waypoints, other guides, having things literally physically in the external environment that provide not only orientation, but also potentially even reconfiguration, whether that's loading something in or even prompting a learning process that would cause the system to adapt and reconfigure itself. Failures of intent versus failures of syntax. So that idea of did you say what you mean or did what you mean end up being the wrong thing to say. Hyperparameters and toggle switches, what was I thinking there? I think just basically the notion of why do you need configuration if there is a right configuration? Why does it need to be written? Can you learn your way into it rather than the set it and forget it notion? Right. So what needs to be set and forgotten? But why have a switch if the on state is always the right state? I guess was what I was saying there. Right? So find out what is truth and what is configurable. And then probably the questions are more useful than the ideas because I don't know. I don't know what I don't know. But yeah, what needs to be sort of, you know, what do you? My father-in-law was a satellite engineer in the 1960s, 70s. It was all about set it, forget it, right? Just get it 100% right. Is there any communication? Is there any externalization? And at what, if things are being applied as a configuration or reconfiguration, at what rate, right? Is there some kind of pulse? Is it a hardware clock? Is it set it, forget it? Fingers crossed. What is disk and what is RAM? Does configuration ever manifest in an analog context, right? Little potentiometers or whatever. It's like, do you need a dial if there is a correct setting again? And what needs to be negotiable in relation to new input? and how do we demystify a dark art? The wonderful config files of SMTPD, if you ever remember those days, were a beautiful language unto themselves. So again, all riffing around config, coming from a very much outsider point of view, but hopefully the fact that I have a naive outsider point of view is useful at least once, because I won't be total outsider from today onward. That's what I've got. Discovery, yeah, it's probably a good way to put it. The opposite of configuration. But then I guess there's probably a middle ground called negotiation, right? What I intend, what you discover, what we then synthesize and intend together is almost a dialectic model. So I think configuration is a really interesting idea in highly robust systems that are intended to be autonomous, right? How can you say it's autonomous if it's configured? Is that what DNA strands are? Blah, blah, blah. Anyway, I probably used too much time. Thank you.
Okay. Thank you. Venkatesh, you're next.
All right. So modularity on an existing bot, this came up, I think, because in our parallel track where we are working on Yasha's converged two-wheeler design, it got me thinking of, can we actually converge the two tracks we are on now and somehow approach Yasha's proposal in a modular way? So this seems to me that the question is basically a stylized version of build versus buy, which is like routine in all engineering. And when you think about like how do you take an existing design and modularize it, to me it sounds like you tear it down systematically and ask how each part can be replaced with a more standard, more general part that lives in kind of like a larger universe of alternatives. And two general approaches that I've seen, at least in my consulting work, is you start with monolithic and then modularize progressively over like design or architecture generations. This is how the semiconductor industry has historically worked. You have a monolithic chip design, then it becomes SoC IP approach. Or you go the other way, and this I saw at Tesla, which is the first version of the design has basically a mad chaotic scramble of buy from anywhere, throw it together anyhow and get it to work. And then you start systematically looking at what you're doing. And mostly when you start with chaos, you start pulling it back in. So you bring more and more functions and parts in-house. So that's at the corporate big company level. But I think the same two basic directions apply for the individual design like a robot. And it seems to me that you can do like almost a stylized thought experiment of start with the idealized design, like completely idealized, completely forget the market and components and stuff like that, and start with almost like an artist sculpture way of doing it. Like, how do you build it if you only had to build one and no cost object? And in some ways, curiosity and perseverance are that example, because that's how NASA works. I mean, they do use source components, but a lot of what they do is just bespoke engineering, and then you work out from there. Versus another approach is you start with a completely minimal core and have a lot of what in aerospace engineering is called hard points. So, you know, an airplane wing with hard points where you can suspend either fuel tanks or munitions or various other kinds of things. So start with a small core and build a lot of extensible hard points, or start with the full idealized design and then commoditize it basically. So take the economic idea of commoditization and run it as an engineering process. Let's see. And yeah, at a practical level, I think the most important thing you have to do is start with the design and separate out the parts that are obviously going to be bespoke, like the chassis and the interconnect fabric type pieces, and then look at everything else as candidates for modularization. In terms of questions, one big category of questions I had was, how do you specifically do this to the design we are evolving on the alternating track, which is the two-wheeler robot that is working title YakRover, that may stick as the actual name. But how do you do that? So some simple examples are put the physical geometry into the space of mechano design. So whole spacings and stuff. So it automatically becomes pluggable into the mechanical universe. If you're using like SBCs, design the chassis to have standoffs so it can hold both an RPI and BBB, which have different holes for holding the cards, right? And if you can have a converged single design. We were talking about this in the Discord. So I was initially thinking maybe you should have like ranges of specs, like the motor should be between this and this amperage and this torque, but maybe you can have like a converged single choice, but that single choice can be extensible in some way. Like you have a standard shaft with a way to attach lots of other things, right? So keep the converged part small and then open up what's not converged. I was also thinking about what are good tests for modularity, and one that occurred to me, apart from, of course, interchangeable parts, one that occurred to me was improvised field repairability. So if a legged robot breaks a leg, can you replace it with like a piece of wood that you just find there, right? And generalizing that, the question I had was, how do you even measure the modularizability of an existing bot? By that, I mean questions like, is Spot the dog from Boston Dynamics more or less modularizable than Roomba, starting with the existing design? So that's an interesting question. I don't know how to answer it. Yeah, that's all I had.
Thank you. Jasha, you're next.
All right. So for the base station piece, that yeah, I definitely was more of a questions than ideas or concepts. For me, a lot of it was about level of centralization and what is constraining that. So really like mission driven and then cost function driven. What is a base station, and what are the key advantages of having anything on the base station? So some of the things that I was really concerned about were, is there a particular reason that, because the base premise for me was, why can't a rover or any usual atom in the system assume a base station role or just be a base station on its own? What does a base station mean in that context, and what does it provide that a node in the system on its own cannot? So the thing that I was really interested in is like, what does a base station require? If it's like a large low density object, perhaps there is a cost function for making that mobile. Or if it's just an outright heavy thing that's hard to make mobile, or if we actually just need large surface area for things like antennas or solar, etc. The other one I was thinking about is, again, maybe if a single node in the system cannot assume the base station role, maybe there is a way to platoon multiple nodes together to form a molecule that can become a base station, whether that be in the sense of compute, radio, it could even be physical. They could all hold hands and link up and form some sort of structure. That was kind of the other concept thread I was running. And then the other thing that I was just thinking about is, depending on what the base station feature, like let's say the base station needs to be a shade, and like this is a good example is the James Webb Telescope, is it has very, very large and low density objects that serve a function, which is to shade from radiation. Maybe that's so incredibly cheap to actually make that you can just create them where required and then abandon them, just because the cost of actually moving it would be greater, or the cost of engineering that base station to be movable, I should say, could be greater than simply building it and abandoning it when required. Yeah, so those are my thoughts.
Okay. So I focused on the power supply, and I had a few ideas. The first one is that the power supply itself can be modular. You know, when you build a small bot, it needs 50 watts. When it gets bigger, it needs 200 watts. So instead of swapping out your power supply, we build power supplies. You can just add blocks to the power supply to increase either the storage, you know, battery life, or how much output it can put out. And that suggests that the, I'll call them power blocks, have their own special connector for mating. So we don't have to generalize our standard connector for all of that. A different approach is to have the power supply distributed. We have one battery here, we have one battery there, and that might result in us having more than one power bus. So you can have the power supply for the left side of the bot and a power supply for the right side of the bot. Another direction is taking the different functions of power, as Eric called it, and separating them out into individual components. So storage is one function, actual power delivery, which includes bus control to make sure you have the right voltage, is another. Power monitoring, who's using power, who should not get, do we have a short? Power source finding, the bot has to find its charging station. And power acquisition, either the functions that know how to connect to the power station or the solar panels. Each one would be its own separate component. I mean, that's exactly the opposite from what Joshua showed us of that little box that has power, solar, storage all in one box. That's exactly the opposite. And I note that if you have separate boxes, they're probably going to be smart boxes. Each one will have maybe a little bit of smart, maybe a lot of smarts. And what I'm noting is that the amount of data that they need to transmit wherever is low. So they wouldn't necessarily have to use the data bus. They could just use some low bandwidth wireless. And in fact, thinking about it, the only thing in our bot, only component, correct me later if you want, that really needs a high bandwidth is the video or LiDAR. Most other components can use a relatively low bandwidth. So again, maybe we can have data communicated by wireless, and then we can have a simpler data power interconnection system. When I talk about this delivery and division into smart components, I'm thinking, for example, of the human body, where we have the liver, which has storage functions and it has energy provision functions, and we have the pancreas, which provides control over who does what. Super oversimplified. Another direction of power is to actually associate the power modules with the components that use a lot of power. So a camera doesn't use a lot of power. It can use a regular bus, but a motor, and this goes back to what Anwar said, that if you have a bus, you have voltage drops and so on, the motor can have its own associated power module. Now you could still have some sort of bus that allows them to transfer power between each other or allows them to be recharged together, but most of the power supply would be local. And that leads me to another issue. If I have lots of local power supplies, taking them out and plugging them in to be charged is a big headache. However, if I'm willing to give up on the design flexibility and requires that power is a single layer that you can put down on top of the robot, maybe it conforms to the shape, but it's a single layer, then I can have that single layer be removed for charging. Some questions that I one, how do we know what the power needs of the robot is when a user can, even if we configured it, the user can just add on some sort of power hungry component? Can we, or should we, leave the power design to the user? In other words, if the user designs it badly, the robot can walk 1 minute and has to sleep for 20. And if the user designs it smart, the robot can run continuously at high speeds. The whole issue of power cycle time, is that some sort of something we want to limit ahead of time in our kit? And last but not least, soft fail. Most annoying thing in a robot is it says, oh no, no power, and goes to sleep. Soft fail would be much nicer. And the question is whether soft fail would be something centralized or whether we can make it something more distributed. Okay, so I have the self-powered smart wheel, and when it doesn't have enough power, it just, moves more slowly. It doesn't just suddenly stop or say, in 3 seconds, there'll be no motion. That's what I have, and Anuraj, you're next.
Yeah, I'll try to keep it short. I just try to list the different kinds of sensors that we could use. And basically, we could categorize them as like large complex sensors and simple sensors. And and like I was thinking, like one of the ideas, like if you could exchange end effectors with sensors, so they should be like modular enough that if there is a manipulator, you could change the end effector with grab something with the sensor itself that could go close to what the robot wants to sense. So this probably requires some self-identification of the rover. So when you plug it on the robot itself, the sensor should be able to tell you, like, I can sense this, I can sense that. And yeah, so this kind of creates different kinds of questions, like what do you want to sense? And the sensors also have limitations on the environment they are put in. For example, there is no magnetic poles on the moon, so you can't use magnetometers. So and depending on where you are going, this will cause different limitations on the sensors that you could use. And depending on the complexity of the sensors, if you want to have some complex chemical reaction to sense something, then probably you need more power for it. So this is related to Mayer's power discussion. And yes, so those were some initial thoughts. Yeah.
Thank
Yeah, I
you.
combined the questions together with it. So
No, so please, now the question is, how much time do the rest of you have? Formally, it was supposed to be done in 3 minutes, but otherwise it would be interesting to do some pairing work.
So let me make a suggestion. I think it's worth finishing this exercise as you had planned. So originally, I think we had 2-week sprints on both the tracks. Let's extend it to 3 weeks. So we'll do, I guess, one more session on the two-wheeler robot next week, Yasha, and then one more session on this modular theorizing next week. But since we have 3 minutes left, maybe we should pick our pairs right now, and we can hit the ground running next week.
I think we have a different situation in what in the YARG and in the modular bot. In the YARG, we have an answer, and maybe we want to make it better. And we have to decide if we want it, but we have an answer already. In the modular bot, we're still floating around. I think we need to decide, how we'll decide. Because it's really apples and oranges.
I think that'll become clearer once we finish your exercise. So we did a little bit of the pairwise thing last time. So what else is left? We've got like maybe 1 or 2 uncovered basic systems, and then half a dozen pairwise things to do. What's the
So
step
we
after
don't
that?
we don't have to do any of the uncovered system. We should do pairwise, but the goal would be that after we did all the pairwise, we sit together and brainstorm together if we can see some sort of gestalt emerging. Okay. So if I were to leave something for people to do at home, it would be spend 20 minutes looking at all of this stuff we wrote down and come next week with 1 or 2 proposals on, having read all of this, what you think a modular system looks like. Because none of this is an actual design of the modular system, it's just looking at different aspects of it. So my next step would not be to do more pairing, but for people to think what they think the whole shebang looks like. And then we try to work towards something that looks like an answer. So I wouldn't continue this exercise giving the schedule. I'd change it.
Yep. So the next session would be the Gestalt Imagination Brainstorm, talking about designs we came up with, right? So that'll be 2 weeks from now, and next week we are going to do a first pass on the system design of the YARG direction, right? Yeah, sure. What do you have planned for next week?
I think ideally next week, yeah, the component selection is finalized and there's a clear path to produce the first prototypes and put them outside.
So I think this is working out naturally to one more iteration on both the modular and YakRover, and then we have a joint session comparing both mission concepts side by side and decide like either pick one or merge them into one project or figure out a way to do both. So I think that's 3 weeks from now. So looks like we have the next 3 weeks in the calendar figured out. All right, sounds good.
Yep.
Perfect. And we're ending almost exactly on the hour. So yeah, welcome aboard, Robert, and hope this was not too much of the deep end. And yeah, actually, what's your quick reaction? Maybe we can get your
The
reaction.
deep end is my favorite end. So yeah, this sounds very interesting. I'm very interested in process. So I'm curious to see curious to see how this evolves, and I enjoyed all the thinking so far.
Right.
It's nice to be out of my depth.
All right. So we'll be back again next week. See you guys.
Thanks.
Nice to meet you guys.